Section 1.3 is covering functions and relations. So a relation is a set of ordered pairs. So it's any graph, anything that you can graph with ordered pairs x, y. The domain of a relation is all the x values, and the range is all the y values. A function, on the other hand, is a relation and where each value of the x, for each value of the x, there's exactly one value of y in the range. So you can't have more than one of the same x value. Like you couldn't have 2, 3 and 2, 5 because they would give you 2 different y's for the same x. So in this example here, it wants you to find out if it's a function. If you look, you've got 2 repeated for the x's, so no, it's not a function. This one, and that should be a comma right there, all the x's are different, so it is a function. This one, you've got the ordered pairs. This is called a mapping. You've got the ordered pairs -2, -2, 6, 6, and pi. And you can see that the x's are not repeated, so it is a function. If this were not a function, a mapping would look something like, maybe like that, where you've got more than one arrow coming out of an x value. Determine if this is a function. Well, if you can solve for y and you don't have a positive and a negative case, then it is a function. So this one is solved for y. You've just got 2x plus 6. There's no positive and negative. And so it is a function. You probably recognize this one as a line. This one, you've got y equals 2x squared plus 6. No positive or negatives or anything, so we do have a function. This one, if we solve for y, and that's not supposed to be there, if we solve this for y, then we get y equals -x plus 7. And so we're good with that. This is a function. For number 7, if we solve for y, we get y squared equals -x minus 7. And when we take the square root of both sides, that gives us y equals plus or minus the square root of -x minus 7. And so because of the plus or minus, this is not a function. This one, if we solve for y, we've got y cubed equals -x minus 7. And we can take the cubed root of each side to get the cubed root of -x minus 7. When you take a cubed root, you don't have positive or negative because the cubed root of a negative number won't be the same as a positive. So this one is a function. The vertical line test. Basically, if you can draw a vertical line through the graph of a relation, then it is not a function. So here you can see if we draw a vertical line, it hits more than once. If it hits more than once anywhere on the graph, even though right here it hits once, if there's anywhere else on the graph that it hits more than once, then it is not a function. This one, we can draw a vertical line anywhere on the graph and it only hits once, so we do have a function. And this one, if we draw the line here or here, it only hits once, but if we draw it right through there, we've got two solid dots. And since they're both solid, it's not a function. If one of them were open, an open dot, then you would have a function. But since they're both solid, it's not. Next, we're going to look at solving for values of x. So f of negative 3 is we're just putting in negative 3 everywhere we see an x. So we've got 2 times negative 3 squared minus 3 times negative 3 plus 1. And we just simplify. So that we've got 18 plus 9 plus 1, which is 28. So doing a few more of these, same deal. Here, this time we're just plugging in the square root of 2 wherever we see an x. The square root of 2 squared is 2. And 3 times the square root of 2 is just 3 square root of 2. So here you have 4 minus 3 square root of 2 plus 1, which simplifies to be 5 minus 3 square root of 2. This one we're just plugging in a everywhere you see an x. And it just ends up being 2a squared minus 3a plus 1. And here we're plugging in 3 plus z everywhere we see an x. Just make sure you use those parentheses so we know to distribute. Now 3 plus z squared, that's 3 plus z times 3 plus z. So you have to full. You've got 9 plus 6z plus z squared. And then here we're going to distribute the negative 3. And I'm going to go through and distribute the 2. And then combine like terms, and we've got 2z squared plus 9z plus 10. This one we're using g of x and plugging in 3 everywhere we see an x. So this is the square root of 6 minus 6, which is just the square root of 0, which is 0. Here we've got the square root of 6 minus 2 times negative 4. So negative 2 times negative 4, that's positive 8. So we have the square root of 14, and you can't simplify that. So that's as far as we can go. Here we're plugging in 2w everywhere we see an x. Oh, sorry. So we have 6 minus 4w, the square root of that, and that's as far as we can go. And that's not supposed to be there. Determine the x and y intercepts. So if you have an x-intercept, that is where y equals 0. If you have a y-intercept, that is where x equals 0. So to find the x and y intercepts, to find an x-intercept, we let y be 0. Because it's where we're crossing the x-axis. So if you've got a line here drawn, the x-intercept is where it's crossing the x-axis, so that would be some a 0 or y 0, and where we're crossing the y-axis, x will be 0 with some y value. So let y be 0. So we'll have, this is the same thing as y equals x squared minus 4. So we've got 0 equals x squared minus 4. And we just solve for x. X will be positive or negative 2. So the x-intercepts are negative 2, 0, and 2, 0. And I do write them as points because that's what they are. Our y-intercept, we let x be 0. So we'll have y equals 0 squared minus 4. So y is just negative 4. So the y-intercept is 0, negative 4. For 15, we do the same thing. For the x-intercept, we let y be 0. So we've got 0 equals 3 minus the absolute value of x. And solve for x. So x could be positive or negative 3. So the x-intercepts are negative 3, 0, and 3, 0. And then for the y-intercept, we let x be 0. Absolute value of 0 is just 0. So y is 3. So the y-intercept is 0, 3. And then this one, x-intercepts, let y be 0. Oops. So we've got the square root of x is 2. If we square both sides, then x is 4. So there's an x-intercept at 4, 0. For the y-intercept, we let x be 0, and the square root of 0 is just 0. So we've got y equals 2. So there's a y-intercept at 0, 2. The next concept we're looking at is domain and range. The domain is all the x values, and the range is all the y values. So the domain here would be all the x values. Now, if this thing continues to go up, it's going to continue to go up and out forever and ever. So we're looking at x values. So it's going to keep going to the left forever and to the right forever. So our domain is all real numbers, or in set notation, or in interval notation, it's negative infinity to infinity. The range is all the y values, so we want to start from the bottom and move up. So the bottom of this is at y equals 2, and then it's going to go up forever. So we're including the 2 and going to infinity. This one, the x values, it's going out to the left. And I'm going to assume this is going to keep going up, up, and to the right every little bit. So it's going to the right also. So again, the domain is negative infinity to infinity. The range starts here at negative 10. And it stops in here, but you can see part of the piecewise function, that's what this is called, keeps going. So it's keep going up and up forever, so it's going to infinity. The next example, the domain is going to the left forever, so negative infinity. And then it's stopping at x equals 4. You can see here there's no arrow, so it's stopping there. And it's including the 4, so we've got to 4 with a bracket. The range, there's nothing down here. There's a spot at y equals 1, and then at y equals 2, it's going up to y equals 8. So we've just got 1, and so you put that in braces, and then we're unioning that with 2 to 8. And since the 2 and the 8 are included, they're in brackets. And then this one, the domain is starting at negative 2. And I'm not really sure what this thing's doing. If it were curling back around, it wouldn't be a function, so I'm assuming it's not doing that. I don't think it would just keep going straight down. I'm going to assume it keeps coming out a little bit over time, like this. Okay, so I'm going to assume for this one that it is going to infinity. Sometimes it's hard to tell. And in that case, if it's going to keep on going down forever, then we are going to negative infinity, but then it's only going up to y equals 4 here. And it's including the 4, so we'll put that in the bracket. And the last concept, we're just looking at this piecewise function and want to answer some questions about it. So the first one, it says find f of negative 3. Well, that's the y value where x is negative 3. So x is negative 3 right here. And so the y value there is negative 3. So f of negative 3 is negative 3. Okay, f of 0, that's the y value where x is 0. So that would be right there at 2. Find all x for which f of x is negative 1. So that's saying find the x's where y is negative 1. So the only place where y is negative 1 is right here, and that's where x is negative 1. Find all the x for which f of x is 1. So that's where y is 1. So y is 1 right here. But that is an open dot. So that's not going to be a case. But over here, where y is 1, x is 2. So we can say that there is a 2 for which f of x is 1. Or that f of 2 is 1. Determine the x-intercept. Where does it cross the x-axis? It doesn't. There's not one, so none. Determine the y-intercept. Where are we crossing the y-axis? Right there. So where y is 2, so the point 0, 2. And last, determine the domain and range. So for the domain, we are, because of that arrow, going to negative infinity, and because of the arrow here, we're going to positive infinity. And there's not a break because of the solid dot here. There's not a break at -1. So the domain is negative infinity to infinity. And then the range, let's see, we're going down from -1 to infinity. So we're negative infinity to -1. And that is including the -1 because it's a solid dot. And we're going to union that with, we've got this break between -1 and 1, but we're starting back at 1, and we wouldn't include it because of that open dot, but because of here we're actually touching, we're going to include the 1 and go to infinity. That concludes section 1-3.